found what the first derivative tells us. Let's see what the second derivative tells us in the concavity. So for the second derivative, I want to look at the easiest first derivative. And I like to look at this guy. I am a little tired of the quotient rule. If I can avoid it, maybe that's not a bad way to go. So I'm going to see my first and my second in the product rule. So now let's just move up and down a little so we don't make a mistake. Derivative of the first is negative 2. I don't know if you can hear, someone is walking upstairs. I apologize if it is noisy on the video. Derivative of the first, negative 2, times the second, e to the negative x squared, plus the first, which is negative 2x, times the derivative of the second, which is e to the something, times the derivative of the something. So it requires a little bit of cleanup here. I can do it in multiple steps, or I can say, well, this guy is in both, so let's take it out as a common factor and see what I have left. I have left a negative 2. And if I put these together, it's a negative 2x and another negative 2x, so there'll be a plus 4x squared. Plus 4x squared. So now let's just see what is the simplest way to look at that and to write that before moving on. I definitely want to move this down. You can take out a 2 if you want to. Sure, why not? And maybe have 2x squared minus 1. Let's just check. Multiply it back in, I get 4x squared. Multiply it back in, I get negative 2. So that's good. And maybe move this guy to the bottom. That's maybe my best option for looking at the second derivative. I then have my 2 checks. When is the second derivative equal to 0? Well, it's going to be when 2x squared minus 1 is equal to 0. So that means x squared is equal to a half. So that means x is equal to plus or minus 1 over root 2. Oh, my bracket is way too short, isn't it? Next, when is the second derivative undefined? When the denominator is 0, but that's not happening because it's e to the something. So that's a never. Whoops, that was only supposed to be never. Whee, like that. So I have my possible inflection points at plus minus 1 over root 2. Not ideal, but it is what it is. Can I squeeze in my table? I'm going to squeeze in everything over here. Why not? I think I can. Now it's split up, my x-axis, into negative 1 over root 2 and positive 1 over root 2. Ooh, that was an ugly one. You can go decimal if you want to, but the root 2 is pretty clean number. So, I have my pieces. Write the 2 if you want to write the 2, because sometimes it's negative and it plays an important role. 2x squared minus 1 and e to the x squared. The only way to get better at these really is to just see a little variety. In the functions, and you get used to them. Used to watch out for, used to where the possible mistakes can be. 2 is always positive. I'm going to do the exponential one next. E to the x is always positive. Oh, that's also very nice. Now, you could factor 2x squared minus 1, but most people, they could make a mistake, so I want to show you don't have to. But I had 2 zeros coming out of that guy. So 0 whenever I have negative 1 over root 2 and positive 1 over root 2. They are in the numerator, so it makes the second derivative 0. Plug in representative numbers, see what you get. It's going to be positive, negative, and positive. It can only change over the zeros, but depending on how simple or not simple your piece, your factor, your expression is, it could change multiple times. So, no negatives in the first section, 1 negative, no negatives. Concave up, down, up. Let's write them down. F is concave up on negative infinity to negative 1 over root 2. Should I include 1 over root 2? Yes, I should. We're going to calculate those values in a second. 1 over root 2 to positive infinity. Squeeze it in. F is concave down on negative 1 over root 2 to positive 1 over root 2. So we just want to find what are the y values in each case. Now you could go decimal. Remember my function? Where's my function? Function up here somewhere. Function up here. So if x is, well, I can see the function. Let's just do it this way instead of scrolling up and down. If x is negative 1 over root 2, then y is 1 over e to the square of this, which is 1/2. Or 1 over root e. You can calculate that on your calculator if you want to, or not. And it's also going to be the case when x is negative 1 over root 2, because I'm squaring it there. So I get 1 over root e. 1 over root e. 1 over root e. Now let's take our calculators and calculate. What is 1 over root e? I'm curious. I want to know. So 1 divided by square root of... Oh dear, where's e on my calculator? Why do I not have e on my calculator? I don't see e on my calculator. I'm just using no, I don't have it. I'm just using a temporary calculator. Okay, hold on. I can do it. 1 divided by square root of e. Go. 0.6065. 0.6065 if I round to 4 decimal places. Alright. So, do I have an inflection point here? Yes, they're points. They come out of my check. The concavity changes, so they are inflection points. Or there are inflection points at these x values. Let's see where this sits. So it's 0.6, right? So it's, let's suppose it sits over here and here. So this is 1 over root 2. This is negative 1 over root 2. And this is 1 over root e. Now I'm bending. How am I bending? Up, down, through the 2 points. Down through the 2 points. That makes sense. Up, up. Okay, so it does make sense. Let's make a nice clean graph. And it's because of the x squared that I don't have the basic e to the x shape that I'm used to. I have 1 here. I'm going to go down, bending, and it's going to change, maybe not right there, maybe over here, at negative 1 over root 2, 1 over root e, and Oopsie. Down. Come on. And bending up to my asymptote. There. At 1 over root 2. And there we go. That is the graph of e to the negative x squared. Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.